Okay, ready to work through another example of hypothesis testing? The average serum cholesterol level in a certain group of patients is 240 milligrams. The standard deviation is 18 milligrams. A new medication is designed to lower the cholesterol level if taken for 1 month. A sample of 40 people use the medication for 30 days, so 1 month, after which their average cholesterol level was 229 milligrams. At alpha equals 0.01, does the medication lower the cholesterol level of the patients? So normally it's 240 milligrams. After they were taking the medication for a month, it got down to 229 milligrams. So that does look lower, but the question is that enough lower that we can be reasonably sure that it was due to the medication and not just due to random variation, chance factors, the fact that different people have different cholesterol levels on different days that vary for all sorts of reasons. So we're going to work through the 5 steps of a hypothesis testing problem. And where it says the standard deviation is 18 milligrams, that'll be the standard deviation in general, just for the whole population. That's not just specific to this sample. So we do know the population standard deviation, therefore we are doing a z-test. Now, step 1, the claim that we're testing is that mu is less than 40. After all, we're trying to figure out, does this medication lower the cholesterol level? Does it make it lower than or less than what it was without the medication? So without the medication, it was 240. So if the medication lowers the cholesterol level, that means that the average cholesterol level of people in this group who take the medication for 30 days should be less than that, less than 240. So that would be the claim. And that does not have an equal sign in it, it has a less than sign. So that would be the alternative hypothesis. It's saying that there is a difference here. So then the null hypothesis would be that mu is equal to 240. The null hypothesis and the alternative hypothesis are always going to have the same number. They're always going to look the same, except that the null hypothesis is going to have an equal sign in it, and the alternative hypothesis is going to have either a less than or a greater than or a does not equal sign. Okay, step 2. This is where we compute the test value, and to do that, no matter what method we use, we have to know what numbers we're working with. So x bar, that's your sample mean. Can you see what that is? What's the sample mean? What's the average cholesterol level for the people in the sample? 229. Their average cholesterol level was 229 milligrams. What is sigma? What is the population standard deviation? The standard deviation is 18 milligrams. What about n, the sample size? That's how many, in this case, how many people were in the sample? 40, a sample of 40 people. And the mu in the formula is the same number that we just wrote down when we were saying what the null and alternative hypotheses were. So that's 240. Now we put all of these numbers into the formula or into the calculator or the spreadsheet or the app or whatever you're using. And let's do it in the calculator. So stat, tests, z-test, make sure we're on stats. Mu 0 is 240 in this example. Sigma is 18. X bar is 229, N is 40, and remember our alternative hypothesis had a less than sign. It was that mu was less than the number 240. So select that. And now go to calculate, hit enter, and it tells us that z equals negative 3.865. That's the test value. And then looking ahead to step 3, the p-value is 5.556 e negative 5. So again, scientific notation, it's this really small number, 0.00005556 and so on. If we did this with the Excel spreadsheet, make sure you're on the z-test tab. Mu0, the number in the hypotheses, was 240. Sigma, the population standard deviation, was 18. X bar, the sample mean, was 229. N, the sample size, was 40. And H1, the alternative hypothesis, was mu is less than 240. So the p-value is 5.554 e negative 05. Written normally, that would be 0.0000555 and so on. So that's our z. Our p-value is 0.00005. And so in step 4, again, we got a p-value that was less than alpha, the level of significance. So when that happens, and we come to step 4, we always say, reject the null hypothesis. So what does that mean for our claim? Remember what the claim was. In this example, the claim was the alternative hypothesis. What did we just reject? We rejected the null hypothesis. We ruled that out. If we rule out the null hypothesis, what has to be true? The alternative hypothesis, which in this case is the claim. So there is enough evidence. We did reject the null, so there is enough evidence to support the claim. Rejecting the null hypothesis is equivalent to supporting the alternative hypothesis, which was the claim in this example. Okay, next time we're going to come back, and in the next video, I'll show you some examples of doing a t-test, which works very much the same way. It's just a little bit different, and I'll tell you what you have to do differently, depending on which method you're using, if you only know the sample standard deviation. So that'll be next video.